how do you write an electrochemical cell? So we start with, or I would start with 2 electrons. These 2 electrons are connected by, could be a lamp or could be a voltmeter. Now, each of this electrode is placed in a solution. Okay, this solution is normally the ions of the metal that we have. Okay, so this is one solution, and then let's do one more of the color here. I'm going quite random in terms of color. Okay, so if you think about how did you write circuit in physics? Yeah, a long time ago, probably when you were doing GCSE, we had ammeters, we have a bulb, we have the voltmeter, this is what it looks like. Now, you need to think this as a circuit. The main requirement for a circuit to function is that it's all connected. Okay, that there are no gaps, because if there is gap, which actually, if you think about in a gap in a circuit, it's a switch, you could add that in a circuit, and you can open and close it, to allow electricity to flow or to stop that. Okay, so in the electrochemical cells, we have something called the salt bridge. So the salt bridge looks like this. Okay, it's actually a kind of tube or soaked paper. Okay, and let's label it. This is a salt bridge. What the salt bridge does, it's a tube of unreactive ions, okay, that can move between the 2 solutions, okay? So they don't interfere with the reaction, but they complete the circuit. They complete the circuit because ions, remember, they flow because they're in aqueous solutions, okay? So they carry the flow of charge, right? Very important, because this allows electricity to flow in our electrochemical cell. Then remember that most of the time, and this you need to look at the electrochemical series and see if you have the solid metal and the solid the metal ion in solution, because most of the time the electrode is going to be made by the metal as a solid, while this would be made, the solution would be a metal in its aqueous solution. Okay. Then, well, to work out what is the positive and the negative electron, you need to think about what is the actual order of the flow of electrons. Okay, and for to write the conventional representation of these cells, I made another video on it, so please click here to watch that video. But let's say that I'm just going to write a quick example in case you're already confident with it, because as you can see, I mean, this is a quite long to write, as a full representation, which means that if we have, let's say this is zinc and this is zinc in solution, which means that it is 2+ ion, and this is copper solid because of the solid electron, and this is our copper solution. Okay, remember that the electrons flow from left to right. Okay, so they flow from left to right. Okay, this is because you would know it by looking at the values of the electric potential, but if that is the case anyway, we will have the zinc solid electrode is in contact with zinc 2+ solution. The zinc 2+ solution is in contact with the salt bridge, which is in contact with the other solution. Remember, salt bridge connects the 2 solutions, which is in contact with the copper electrode. So we will know that zinc is, goes from zinc to zinc 2+, so it's the one that it's oxidized, while copper is the one that is reduced, okay, because it goes from an ion to a solid. So very important exam questions here would be the use of the salt bridge and one example. Here there are tricky questions. For example, if you have, for example, let's say that you have one cell that it's with silver, then your salt bridge cannot contain chloride ions. Okay, for example, you can't use potassium chloride for this because it would react with the silver, forming a precipitate. So these are the tricky questions that you may find. And the classic exam question is suggest why silver can be used for this cell. Things like that, which means that they must be unreactive ions. So many times you have a potassium carbonate or potassium chloride, any ionic compound, as long as it's not reactive. So this is the thing to keep in mind. Okay, so I hope you understand the representation of the cell. For the conventional representation, there is another video to watch, and the important thing about the salt bridge.